My name is Marco Pereira. In 2005 I created the hypergeometrical universe theory. The hypergeometrical universe theory was the result of exploring not the most sophisticated possible model but the simplest one. It wasn't clear to me why the proverbial balloon, a lightspeed expanding hyperspherical universe topology or LEHU, wasn't part of the discussion. I wasn't happy with the Big Bang model and decided to explore LEHU as an alternative. In doing so, I realized that for me to create a 4D model for electromagnetism, the mass of the electron would have to be around 1 atomic mass unit, or the mass of a hydrogen atom. I put 1 and 1 to make 2 and proposed a new model for matter in a 4-dimensional universe. That was the motivation for the fundamental dilator. This path leads to the simplest possible understanding of the universe, the most fundamental theory of everything. My theory is expansive and touch many areas. That said, I am sure there is still work to be done and future generations will be able to expand upon what I did. It turns out that people before me considered proposing it. Richard Feynman might have been one of them. The reason Feynman failed was because LEHU is not a solution to Einstein's equations, and anyone that might propose it would have the tremendous burden of debunking Einstein's ideas and replace both special and general relativity with a new model. Since the proverbial balloon is not a theory and since Einstein's ideas are in all mainstream models, nobody ever overcome those barriers until now. The hypergeometrical universe theory contains 3 hypotheses. The universe is a lightspeed expanding hyperspherical hypersurface. Here you can see yourself at position A, looking into the sky and seeing light emitted by a Type 1a supernova, SN1a. When it was at position B and the universe was smaller 4D radius, denser, and more homogeneous. Notice that the universe and all its stuff is at the hyperspherical shell locus and that locus expands at the speed of light. Notice that there isn't any brain, structure connecting galaxies, etc. Who shows that the receding of galaxies is because they act exactly like dots on a balloon. That is, they travel along the radial direction, perpendicularly to our 3D space. Hence, who does not use or need dark matter, dark energy to explain reality. The second hypothesis states that matter is made directly and simply from localized shapeshifting deformations of space. The monomeric unit is called fundamental dilator, FD. FD is a coherence between stationary states of deformation of space. Notice that I said space and not spacetime. Spacetime plays no role in the hypergeometrical universe theory. Here you can see the fundamental dilator representations of the electron and positron particles. The letters orientation maps the phase's orientation with respect to our 3D universe. Vertical letters indicate that that phase is perpendicular to our 3D universe and does not interact. The closed loop indicates that the coherence will repeat for the lifetime of the particle. Here you can see the fundamental dilator representations of the proton and antiproton particles. Neutrons contain fundamental dilators for electron and proton plus 2 transmutation chords, shown in red. The transmutation chords correspond to half antineutrino each and map to rotations within the 3D hypersurface, as opposed to spin, which happens in 4D. Notice that W- is just a state in the decay process. One can understand this in terms of transition state theory. Notice that neutron is a dimer. This is because there is uncertainty on which is the initial phase, the electron or the proton. The hypergeometrical universe theory provides a physical justification for one of the biggest mysteries of quantum mechanics. What is the reason for the Pauli principle? Just saying that electrons are fermions doesn't mean anything. The fundamental dilator paradigm shows that it is alignment of opposing charged phases during the non-interacting phases of the coherence that explains the exchange interaction. Of course, by non-interacting phases we mean the phases that are perpendicular to our 3D universe. The quantum Lagrangian principle, QLP, as fundamental dilators shapeshift and spin in 4D, they create metric waves. QLP states the fundamental dilators will move into positions where they dilate space in phase with the local dilaton field. That is the simplest no-work constraint possible. It is also the fundamental law of physics. From it all laws of nature can be derived. Notice that if one knows where the fundamental dilator is at every time and knows its 4D mass, one knows the force acting upon it. Here you can see the fundamental dilator interacting through the metric waves they generated. Notice that lambda is the Compton wavelength of a hydrogen atom, since the 4D image of a fundamental dilator contains both the proton and electron phases, and the fundamental dilator is traveling at the speed of light along the radial direction together with the universe. The universe is seen as going through a stepwise expansion at the speed of light. At each step, the fundamental dilator tunnels through its 4 phases. More complex particles are isotopes or polymers and also perform a rotation in addition to spins. Notice the 2 different distances shown in the figure. Lambda is the Compton wavelength of a hydrogen atom, around 1.32 e-15 meters, and the other is the 4D radius of the universe, 14 billion light-years or 1.32 e+26 meters. Those distances map to the strength ratio between electromagnetism and gravitation, 1 e-41. Notice that to satisfy the quantum Lagrangian principle, QLP, the fundamental dilator has to move x to the side. That can be done in 2 ways. One is shown where the fabric of space just twists by alpha 1. That has the highest twisting angle and thus the highest acceleration. The second way is to just slide on the fabric of space and have its normal aligned with the radial direction. That is matched to gravitation. The elasticity of space introduces a residual twist extremely small when compared with electromagnetism, alpha 1, but significant when compared with gravitation, alpha 0. Who uses this residual twist to derive the natural frequency of space deformation waves. Here you see 2 cross-sections of the lightspeed expanding hyperspherical universe. There are the 2 reference frames from relativity x tau and x_prime tau_prime. The angle of twisting is mapped to the twisting of the 3D overlap volumes of the fundamental dilators with the 3D hypersurface. They act like surfboards. In the hypergeometrical universe theory, all particles surf the inner dilation layer, a remnant of the Big Pop universe creation. Right below, you can see Newton's equations translated into the space-strain-stress paradigm of the hypergeometrical universe theory. Notice that Who is a 4D spatial manifold theory, and the derivation of forces have to be done in the 4D spatial manifold. Dynamics always occurs in 4D spacetime. Notice that the 3D mass only sees half of the phases of the fundamental dilator. This is a requirement since 3D masses are the inertial masses of particles. Who introduces the stress-strain paradigm. Stress is equal to area times strain. Area is mapped to the 3D volume of particles, represented by fundamental dilator polymers. Strain is the derivative of the hyperbolic tangent of the fabric of space twisting angle. Particles' 3D volumes are footprints of the fundamental dilator, a 4D construct. The angle between the normal to this 3D volume and the radial direction of expansion of the universe within the 4D spatial manifold, is mapped to stress. A relaxed fabric of space means zero stress, or the normal to particle 3D footprints is aligned to the 4D radial direction. Who postulates that the strain on both cross-sections is the same. In other words, the force calculated using the quantum Lagrangian principle in the 4D spatial manifold is the same as the force to be used in spacetime dynamics.